Well, they're vastly important.
They mean life, passion, awe, wonderment.
Well, I think they're a very important source of life and energy.
It's wild, exciting, terrifying, exhilarating.
It's our livelihood. It's been there for generations and hopefully will be there for generations to come.
I love going there with my family to have loads of fun, mess about and play loads of games.
It actually means a lot to me because if something happened to it, I couldn't have as much fun as I used to be able to.
An incredible source of food and an amazing source of biodiversity.
Well, they're really the heart of the matter. They're what makes where we live different from anywhere else that we actually know exists.
The oceans mean many different things to different people. They cover around 3/4 of the Earth's surface and contain more than 90% of living space on our planet. Yet only recently have we begun to put a tangible value on the oceans, whether that be as providers of food for billions of people worldwide, whether as the main transport system on our planet carrying more than 90% of world trade, or as a reservoir of fuels like oil or renewable energies such as wind, wave and tidal power. They contain the vast majority of life on Earth, and through the plankton they affect our climate and give us every second breath we take.
Even for those that live many miles from it, the ocean is our life support system. It connects every one of us. You could think of the ocean as the blue heart of this planet. But are we looking after that heart? Do we know how we're damaging it? And is it in need of some intensive care?
We know our oceans are not indestructible. Fishing stocks have dwindled perilously close to extinction. Pollution incidents are an almost daily occurrence, while a growing population, habitat destruction and coastal development proceed at an alarming rate. Our footprint on the once invulnerable seas is a very large one.
Now the oceans face another challenge, one that's only recently come to light, but one that threatens the very life in the seas, and that means us humans as well. This is ocean acidification. Like climate change, it's caused by the massive amounts of CO2, carbon dioxide, that we've pushed into the atmosphere since the beginning of the Industrial Revolution. Over the last 200 or 300 years, much of this carbon dioxide has ended up in the sea. Now, when carbon dioxide and seawater meet, two things happen. The chemistry is quite straightforward. On the one hand, there's an increase in the number of hydrogen ions, and what that does is pushes the seawater down the pH scale towards acidity. It's about 0.1 of a unit. It doesn't sound much, but actually in real terms, it's about 30%, and that's very significant. The second thing that happens is that the amount of carbonate in seawater is reduced. Now, a lot of creatures need this carbonate to make shells and skeletons, and so they're obvious candidates, obvious victims, if you like, of ocean acidification. But as scientists understand more and more, they're worried that the ramifications, the impacts, are going to be much more widespread. If the ocean's impacted, so are we humans.
It is still very early days and the science is not clear. Across the globe, scientists have been mobilised into research programmes and collaborations to look at every aspect of what the impacts of ocean acidification are and how they may affect individual organisms, ecosystems and ocean food webs.
Here we have, in only 200 years, we have reached ocean acidity levels that have not been reached in the past 55 million years. This is going extremely fast, and this is a concern for the ocean life.
So the ocean acidification research that we've been doing has shown a 30% reduction in shell weight in microscopic organisms in the Southern Ocean called foraminifera. These guys are already quite light, so if this continues, and we think it will continue, it's going to severely impact their food sources for commercial fish, whales, seals and penguins. And they also have a second function in that they trap carbon and transport it away from the atmosphere.
According to the research of scientists involved in my organization, We believe that there will be impacts on different types of organisms. There's some evidence that coral reefs cannot survive under the types of pH and CO2 levels that will exist by the middle of this century.
Well, ocean acidification is impacting organisms. We know this from laboratory experiments. So we know that calcifying organisms perhaps are going to be affected because they've got these calcium carbonate shells which could dissolve. It's changing perhaps the way that their energetics are working, so that has implications for how they grow and reproduce and develop.
I think ocean acidification is the evil twin of global warming, and I think it's insidious, and if we don't do something about it now, it's going to be more important than a warming ocean or an overfishing ocean or a polluted ocean. I think ocean acidification is the most important scientific crisis that we face today.
When people ask me, at a dinner party, someone will say, I hear this ocean acidification thing is going on. What should I know about it? And I tell them it's urgent, it's now, but I think about it in terms of my own children, my own lifetime. And it's something that I certainly hope that as a group we can address now and convince people to do something about it now so we can avoid the ramifications in the future.
So we know ocean acidification is real, we know it's happening now, and we know it's going to affect ocean food chains. But it's the unanswered questions that are perhaps the most worrying. When will that impact take place? How will it manifest itself? And how will that affect the human race? And what, if anything, can we do about it? We cannot be complacent about what we might be doing to the oceans simply because we don't have all of the answers. However, scientists do know enough to be concerned. So, whilst we might be the cause of the problem, there's little doubt that we also have to be the solution.
Global solutions have to be sought for global challenges, and that means international policy agreements. How can a policymaker reach decisions based on uncertainty and early projections? How can scientists put their case in a way that will galvanise the decision makers? And what about you and me, the general public? What are we supposed to believe? And more importantly, is there anything we can do? Getting everybody speaking the same language so there's common understanding is one of the great challenges faced by scientist, politician and public. A very effective way is to get the interested parties around the same table, discussing the same topics from their own points of view. The ocean acidification community has done just this through a reference user group, which brings together representatives from the various stakeholder groups, including scientists, policy advisors and industry. The result is much more clarity and unity of understanding and purpose.
The reference user group meetings are extremely useful for sharing early information arising from scientific experiments, even ongoing work, and also exploring ways in which that scientific information can be rapidly disseminated.
You can take the world's smartest scientists with the best ideas, but if they can't be conveyed to policymakers, those ideas are going to be lost. That's absolutely critical. The communication between the public and the policymakers is also essential because the public are able to voice why they care about the marine environment and why they care about the resources that are likely to be affected by ocean acidification.
Everyone has a different perspective and a different need, and the only way we're going to actually get effective answers to the problem and effective movement towards these solutions is by working together coherently.
Well, I think, this is not the fight of one entity or one group of people. We need everybody.
The scientific community needs to work with government, the private sector and civil society. No one set of actors alone can address issues such as climate change or ocean acidification. Therefore, people need to know what the risks and the benefits are of different actions.
Policy is effectively how you get things done. Research is there to inform, but unless the politicians are well informed and have the right policies, they're not going to take the right actions.
Headway is being made in the dialogue, but these are very difficult issues. Carbon dioxide is related to energy. Energy is related to economic growth, and therefore, as we argue that we need to reduce the threat of climate change and or ocean acidification, we will have to change the way we produce and use energy, the way we manage our land as well.
Ocean acidification and its potential impacts might have crept up on us, but it's now being taken seriously by scientists and policymakers. The key to fully understanding the ocean acidification challenges and the actions that necessarily will follow to alleviate or mitigate against them in the future will be effective and reliable communication between the various interest groups.
As far as ocean acidification is concerned, things have got off to a good start. The scientists, politicians and other stakeholders are talking to each other, but it's not just up to them. Each and every one of us can make a difference. Those differences might be small, but after all, it's individual, small drops of seawater that make up the vast ocean.